This is going to be the recording of chapter 7. Now for this chapter 7, I'm going to divide it really in different sections. So they're going to be like 7 videos probably. Okay. First video is going to cover project until 733. Then we'll do deflections. Then we're going to design examples. There are several examples. We're going to divide it in 2, and so that gives me 2 more videos. And finally, we're going to do again the design of compression reinforcement. So chapter 7 really is design. So now we're going to get into design. Okay? So let's start some of this. Here we are going to do, as I said, design. In beams, what is typical is that you will design for the moment, the bending moment, and then you size your beam based on moment and everything, and then you will check your beam size for shear. Okay. Now, of course, we are really looking at the strength design, but like anything else, the design has to satisfy also serviceability requirements, like deflections, cracking control. So those things have to be part of your design. Okay? Now, detailing of beams, there are several requirements really, and some of those have to do with the cover, the spacing that you can have between bars, and this is important because remember you're going to build a cage of bars, right? And then you're going to pour into that form and the cage, you're going to pour a liquid material, which is the concrete at that time, is liquid, right? But it has aggregates, it has sand, it has all the liquid with those aggregates and all that has to flow through, right? So you put your bars too close, then some aggregate may be trapped in there, and it will not let the cement and all that go around it. So that's very important that you keep then a proper spacing of the bars. You also need to look at constructability, right? Then in the terms of structural requirements, there are things like development length. That's going to be like chapter 11 when we're going to do that. The same for splicing of bars, cutoff points, standard hooks, all that is chapter 11. Okay? So we're going to look at that in chapter 11. For now, then, this part right here is mostly the basic detail. So we're going to start with the cover, and ACI 318 from sections 20.5.1.31 through 1.34 have all the different requirements for cover. And so if I go to ACI, then chapter 20, right? So this is really steel reinforcement properties and durability. And so in this chapter for steel, besides giving you properties of steel and all those requirements, there is, right, the requirement for covers. Okay, so that is what you're looking here, but everything relating to steel is going to be here. So let me try to make it a little bigger. All right. So here is the cover. This is a specified concrete cover for precast pre-stress. Okay, that's precast. So we have one table for precast, non-pre-stress, or pre-stress concrete. Then before that one, we have a specified concrete cover for casting placed pre-stress concrete members. This is the one we were going to use, okay, because our course is casting place concrete. Okay? So we're going to do this one. Oh, but wait a minute, this is pre-stress. Yeah, so let me go back. This one, non-pre-stress, sorry. So 131 this is the one we're going to use. Cast in place, non-pre-stressed concrete members. Yeah? So you give you the table. I mean, here's the table. That's what I copy pretty much in the lecture on the notes. So there is the case of cast against and permanently in contact with ground. And all members will be having a cover of at least 3 inches. Yeah? Now, what does it mean by cast against and permanently in contact with the ground? These will be typical of some footings, right? Foundations, right? Where you dig a hole and you don't put a form around it, right? And then you just put the concrete against it, then you need to have at least 3 inches. Okay? The other one is this one, the second one. It says exposed to weather or in contact with ground. This one is where you can dig a hole, for example, right? But you will put a form to place the concrete. After you pour the concrete in the hole, you remove the forms and you fill it with ground. So now your concrete is going to be exposed, or is going to be in contact with ground. But it was not cast against the ground. Okay? And so in that case, the cover goes to 2 inches. You're using number 6 to 18 bars, or 1.5 and you're using number 5 bars or smaller. Right? So the difference between these two then is, in the first one, the concrete is being cast directly into the ground. The ground is your form. Okay? In this one, you do have a form made out of wood or plastic or metal, whatever, right? You pour your concrete. Then at a certain point, when you've got enough strength, you remove the form and you fill the hole with dirt, all right? And then you make it to be in contact with dirt, and then you use this. If it's exposed to weather in general, like for example in bridges, decks, or balconies, right, that will be exposed to weather, you may want to have also this kind of cover. Okay? Now, if it's not exposed to weather or not in contact with ground, which is the cases that we have mostly in buildings, right, then we are looking at a 1.5 inches, right, for slabs, joists, and walls. If you are using number 14 or number 18 bars. Now, typically you will not use these bars on these elements. So you're looking more at this case, number 11 and smaller. So then you would have 3/4 of an inch. Okay? So slabs, then joists and walls, you can have 3/4 of an inch. For other members like beams, columns, pedestals, anything else, your primary reinforcing, your ties, your stirrups, everything, at least 1.5 inches. So these are the numbers to remember. Then the cover for a minimum cover for slabs, 3/4 of an inch, and the minimum for beams, 1.5. Right? Now remember, all these values have tolerances. Okay, so when you're building, there's a tolerance, and so the tolerance, I mean, can be 1/4 of an inch, even 1/2 inch, and so you may have at the end, you may have really a cover of 1 3/4. You may have 1 1/4, right? So it depends on how things are built, but there is a tolerance. So you don't expect that everything will be exactly 1.5 inches. Mm-hmm. But this is the one we are using for our covers. Okay, so that's what is in this reproduction of that table from the ACI code. Clear spacing between bars. This is more of a construction, so they put it in chapter 25 in the ACI code. Okay, 25.2.1 give you that, and it tells you pretty much that your clear spacing horizontally between bars should be at least equal to the diameter or larger adjacent longitudinal bar. Mm-hmm. So whichever is the largest, you will have that. In this case, for example, these are what we call bundle bars. These have equivalent diameters. So your clearance distance will be controlled by this diameter, right? Between these two, of course, they are the same size bar, then one of these controls the minimum here. Or it could be 1 inch. Oh. So far, I mean, if you are using bars less than 8 inches, then less than number 8, excuse me, which is already 1 inch diameter, then the 1 inch controls. Then you have the 4/3 of your maximum aggregate size. That has to do with your mixed, right? So your mix uses a 1.5 inch aggregate, then you have to multiply that by 4/3, and that gives you the minimum spacing that you can have right in there. Right? Now, a lot of mixes use it like 3/4 of an inch aggregate. So you 3/4 times 4/3, that gives you also 1. So 1 is so far kind of the controlling value. Mm-hmm. Vertically, you have to put your bars right on top of each other, and the spacing is set at 1 inch minimum. You can have more, but minimum is 1 inch. Okay. Now let's talk about these groups of bars, which are called the bundle bars. Okay. So sometimes you may need large areas, but if you put too many bars, I mean, then you get pretty crowded. So the code allows you to bundle the bars and make it like an equivalent new bar, right? And you can bundle in 2s, or in 3s, or in 4s. Okay? So they're shown here. Okay? 2s, 3s, 3s, 4s. Okay? It is not recommended to bundle bars larger than number 11 in beams. All bundle bars should be enclosed by stirrups, and you should use the least number size, number 4 stirrup. Okay. Now you can only have a maximum of 2 bars in a given plane, so that's why you have this shape. See, so you have 1 and 2 bars in this plane. I have 2 bars in this plane, 2 bars in this plane, 2 bars in this plane. I cannot have more. I have 2. I have 2. Okay? I got 2, 2, 2, 2, right? 2, 2, okay? 2. So I cannot have more than 2 bars in a given plane. Okay? This is important. This part has to do with cutoffs and staggered points. So you don't need your bar because your moment got lower, right? You have maximum moment and then your moment is lower. Then you don't need to carry that bar all the way through. You may want to cut it. So if you cut it, then what it tells you here is that don't cut all the bars at the same location. You will cut 1 bar where you need it, and then the other bar will cut out at least another 40 diameters. Mm-hmm. So that way all the bars are not cut exactly the same location. Otherwise, that causes a reflection crack, and you may get a crack on your structural element. Mm-hmm. So that's the purpose of this, to avoid some cracks that may develop on those cases. The unit will have an equivalent diameter, so when you decide on your spacing, all that, there's a diameter that will be used for those bars, right? So in number 6, with a 4 bundle, has an equivalent diameter of 1.5. So that will be the D sub B that you will use to find your spacing of the longitudinal bars. So that's what this table tells you, what are the equivalent diameters of the different bundles of bars for different sizes of bars. Okay. All right. So summarizing this, I mean, this is only talking about cover, which we kind of already knew. We were using these numbers already, right? And clear spacing. So this is kind of new, except that I already told you about this one, but this horizontal spacing is something new, right? So we had this requirement to satisfy horizontally. Right? And then they use bundle bars. That, as I said, is is something that could happen when you have to put lots of bars, but we probably will not get into those cases for us. All right. The next thing is how to design these general ideas, right? And that's where you're struggling right now, right? Because I asked you for your project to come up with the dimensions, but I didn't tell you anything about how to do it. Okay, here now you were going to have some ideas. Right? The overall depth of a beam, H, is in general given in whole inches. Okay? 14, 15, 16, 17. However, if you are doing a joist floor system, joist may end up in 17 and a half or 18 and a half, 18 and 3/4. All right. So joist may have a different depth of beam because of that. Okay. But in general, you should strive for whole numbers. The width of the beam usually goes as even numbers, 10, 12, 14, 16. But I mean, you can use really anything as long as you have the form. We're trying here to make sure that we use the lumber, right, sizes so we can form it. And so that's why we use 10, 12, 14, and 16. The beam effective width, right? No, that's not correct. Let's change that. That should be the beam effective depth. Okay? Remember, you divide. Okay? You divide. It's seldom a whole number. Right? Because the whole number is the H, but your D does not have to be an exact whole number. Because you're going to subtract your cover, your size of the stirrup, right, your bar, so you may not have an exact even number. From a structural point of view, the most economical rectangular beam, right, is one that has an overall depth, that is your H, okay, to width ratio between 1.5 and 2. That's the idea. So lots of depth and narrow, right? But not all the time that's possible, right? So this is just an idea. For example, for beams that are part of a joist system, those of you that have joists, the opposite is true. You want to have more width than depth. Mm-hmm. That's because from the construction point of view, that's easier, and it makes the system more economical. So it's not better for structural analysis, for capacity, but it's better for construction. And so construction takes over because it's more expensive. Right? Now, the beam depth is normally controlled by any vertical clearances that you want to maintain in your rooms, right? And of course, the deflection limits and whatever your architect wants to do, right? So that's why you need to decide on your total depth. In general, you should use the same beam size from span to span to span. Mm-hmm. Don't make your beam have different depths. No. You have different moments, right? In order to carry different moments, what you will do is you will change the amount of reinforcement that goes into the beam, but whoever is looking at your beam from the outside sees only one size beam. Mm-hmm. That person doesn't know that inside you have changed the amount of reinforcement to carry the different moments that you may get from the analysis. Your beam width should be equal or greater than the column width. Equal or greater than the column width. Again, that provision has to do with constructability. Okay? If you make your beam width narrower than the column width, you have to form now around the beam and around the column. Okay? So that's extra labor, extra forms that you have to put in there, and so it's best not to do that. And so then make your beam width equal to or greater than your column width. Through the whole floor system, right, you want to maintain your beams to be very similar. That may not be possible in other cases. For example, you may be right at the landing of a stair, right? That beam may have to be deeper than the rest of the beams, maybe. Or you may be working with the area around the elevators, right? Or you may have a heavy mechanical equipment area. Oh, those may have to have deeper beams, right? And so there are cases where, yes, you cannot do that, but for most parts, you should have a uniform size of beams. Yeah? So that's beam dimensions in general. For your reinforcing bars, right, select bars such that symmetry of the cross-section is always maintained. You always have to provide bars at the corners, so at the minimum you will have 2 bars in tension. And of course 2 bars on the opposite side, which is your compression side. But remember, we said those bars, since we're not designing for those, we don't count on those, right? They will give us more ductility, but we don't count on the strength. The strength is given by your tension bars. Typical beams in buildings use number 11 or smaller bars. So I don't want to see that you're putting number 14s or number 18s in your beams. Your beams should have number 11 or smaller. When using different bar sizes, so you find your area of a steel, and you go to your table and you try to pick up your bars, and you are combining different sizes, right? So either in 1 or 2 layers, do not use more than 2 bar sizes. Okay? So don't try to mix, number 8, number 9, number 10s, all in one. No. Only 2. Either in number 9 with a number 10, or number 9 with an 11, all right? Or a 10 with an 11, or an 8 with a 10. Right? But only 2 bar sizes. That's one requirement, 2 bar sizes. Okay. Keep the symmetry of the beam, and do not use bars that are more than 2 standard sizes apart. Okay. So what does it mean? If I'm going to use number 8 bars, and I need to add more bars, right, to complete my area, then I can go down to a number 6, or a number 7, or I can go up to a number 9 and a number 10. But I should not combine a number 8 with an 11, because that's more than 2 bar sizes. I should not combine a number 8 with a number 5, which again is more than 2 bar sizes. So that's the idea, okay? So you want to maintain no more than 2 bar sizes. You are combining different bars to get your areas. Okay? So from the number 8, you can combine with number 7s and number 6s, or you can combine with the number 9s and number 11, or number 10s. You cannot combine a number 8 with an 11, or a number 8 with a 5. Okay? The best, of course, is to use the same bar size. That's the easiest for construction. Right? If possible, it is best to place bars in one layer. the minimum number of bars that you should use should satisfy cracking control. Now, we haven't looked at this yet. We'll see later, but that's important, okay? So that will be the minimum that you should put in there, okay? And in general, you will have either 2 bars, because you need to have the cage, and for most typical widths, you will not probably exceed 6, okay? However, I mean, you do joists, you may have a beam that is 36 wide. Okay, in that one you can put lots of bars, okay? You can put more than 6 in that case. Okay? But usually 2 to 6 is kind of the typical limit. Okay? Grade 60 reinforcement bars whenever possible. Yeah, most cases is the most common grade of steel, grade 60. So going to a higher grade of steel adds more cost, for now, right? This will be changing, of course, as we make more and more of these higher strength steels. But if for some reason you get that you're getting too many bars in your beam and it's getting crowded, then you can move up to a higher strength steel. But check that it's available. I mean, they may not be available in the area, right? And so you may want to always ask around you have those bars available. Here, telling you to follow the requirements of 25-1 and 25-2, and this has to do again to the covers and the spacing between bars. Notice that, for example, here, an ideal spacing between bars, even though remember the minimum is the 1 inch of the diameter of the bar, here he's saying, guys, at least keep it at 3 inches. I mean, you could, because that's best. You have enough room to put your concrete will flow very nicely, so keep that spacing at 3 inches as you could. We'll find out that that's not always possible. Yeah? If you have different bar sizes, right, then place the larger bars closest to the tension face of the beam. The reason for that is that if you put the larger bars close to the tension side, then you have the largest D possible. And you have the largest D, that means you have more moment, right? So that's why you want to put it at the closest to the tension side. To simplify the construction and site labor costs, provide a smaller number of large diameter bars rather than many smaller bars. What that means is that you have an option between 3 number 11s and 6 number 8s. 3 number 11s is better than 6 number 8s, as long as cracking control requirements are satisfied. Yep. And there is a table 7.3 that's down coming here that has some common recommendations. Yep. So whenever possible, use the minimum number of bars that you can put to satisfy your strength, but at the same time they have to satisfy cracking control. Yeah? If for some reason you need to have more bars in order to control the width of the crack, then you go for putting more. But in general, try to use the lowest number of bars possible that you can have to carry your load. Use tie wire to maintain the integrity of the caging during construction. Do not weld around it, okay? So you just tie with wire. So really all you did is you just had little wires and you attach your longitudinal bar to your stirrups, making sure that is in place. Let me see if I can get something for you. That is the problem. So let me fix this quickly here. All right, so now we're good. So what I would look, okay. Let me see if we have anything here that we can look at. See what these guys do. Kind of. But you see little things here like that, right? So these are kind of the ties. Tying. You're tying your stirrup to your bar so it will remain in place. And you have to do that. Notice here. So here they have all these wires, right? And they have these hooks. I mean, the guys are pretty fast. I mean, you're hooking them and then kind of turning around. And notice how you create the ties there, right? So you're tying during construction so these bars will not move. So you have to do that. You know? Otherwise, I mean, when you start pouring the concrete, you don't have this tie. I mean, things moved. I mean, this is create a lot of pressure. So definitely you want to have those. And that shows you, I think, the best on that. Okay? So don't confuse these elements, which are the tying, just to tie the bars here together, with what we've been calling ties in columns, right? Or stirrups in some cases, right? So those are different. Okay? The tying is done simply with wires. Okay? Just to get it in place, to just keep things attached so they will not move. So here it is, another one. Okay, so that one is a good one. So notice how you got the wire around, kind of tying things together so it will not move. Okay? So that's the purpose of that tie. All right. So let me go back then. So that's what they mean by that. Okay, tie wire. Okay? So not welding, because rebars, unless you ask for special rebars, they're mostly not weldable. Okay, what are the things recommended in 7.3? Recommended minimum and maximum number of longitudinal bars in a layer. A width of 8 inches, too small. So you're giving me a beam of 8 inches in your project, that's not good. Okay. You need something greater than 8 and less than 10. You can put 2 bars. Between 10 and 12, you can put up to 3 bars, and then depending on the size now, greater than 12 inches, you can put different numbers of bars. Okay? And so I would say at least 12 inches minimum to have enough space to put bars. Right? Okay, so I'm going to stop this video here, and next video is going to be on serviceability. Okay?